Hello, in today's video we're going to be discussing section 8.3, which is on graphing quadratics in standard form. Our essential question today is how can you find the vertex of the graph of f of x equals ax squared plus bx plus c. This form is what we call standard form of a parabola. It has not been factored in any way. Everything has been multiplied out and simplified completely. I'm going to ask you to take a moment to pause the video and in the same coordinate plane, maybe using two different colors if possible, go ahead and graph the two quadratics that I have shown here. At this point, it's probably going to be the easiest to just create a table for yourself. I would put 0 in the middle and then two numbers below and two numbers above 0 for each of your graphs. This is my strategy. If you have another strategy that you prefer to use, feel free to go ahead and do that. But go ahead and pause the video now and graph both of these parabolas. If you did decide to create a table or complete the table that I have started, when I plug in a 0, I'm going to get 0. When I plug in a -1, I'm going to get 10. When I plug in a -2, I get a positive 24. When I plug in a +1, I get -6. And when I plug in a +2, I get -8. So plotting these points, -2, 24 is way off my graph, -1, 10 is here, 0, 0 is at the origin, 1, -6, and 2, -8. Well, we know because this is a quadratic, it has x to the second power, that this should be in the shape of a parabola. If I connect what I have right now, connecting all four of those dots, I don't see any vertex or point where my graph is going to turn around. It looks like it's getting close to turning around here, but we're not sure because we don't have enough points in my chart. So I'm actually going to go ahead and add another one. I'm going to add 3. And when I plug in a 3, 2 times 9 is 18 minus 24 is going to give us a -6. So we do get that vertex, or what I've been referring to as your turnaround point. So 3, -6 is here, and we see that if I do connect all of these dots, my parabola does U-turn right at that point to -8. So my graph would look something like that. And we call this point here our vertex. It is that turnaround point or that peak of our parabola. Graphing our other parabola, our second parabola in this case, I have my first and my second one will be in blue. Both of these parabolas look very similar, but one is a little bit higher than the other. If I look at their equations are very, very similar to one another, but my second equation has a +6, while my first equation has a +0 or no constant term. So we're going to be exploring a little bit how these values are going to affect our graphs. Before we move on, I do want to talk about a couple things regarding parabolas. First is that parabolas are symmetric. Just like butterflies or faces or many things that we talk about when you first learned about symmetry, we can essentially fold a parabola down the middle and it will stamp identically onto the other side. So if I were to draw a line, I'll do it in green, down the center of these parabolas, they both have that same line. If I folded this entire graph over that green line, this left-hand side of my graph would fold and stamp exactly on to that right-hand side because my graph is symmetric. Same thing for my red graph. If I look at the left-hand side of my graph, that left-hand side, if I folded my paper directly on that green line, it would stamp perfectly on top of the other half of the graph. We call this green line that I've drawn our axis of symmetry. Or AOS, as you will see it abbreviated many times throughout our notes. So parabolas are symmetric, meaning that they are identical on left and right sides of the vertex. So that entire left-hand side of my vertex is here, right at that turnaround point. The entire left-hand side that I drew in solid dark red is the same as the right-hand side of my vertex. The axis of symmetry as I've already drawn for you in green, represents the line over which your graph is symmetric, meaning we can fold it directly on that line and the left-hand side will stamp exactly perfectly on that right-hand side. I want to go back to our graphs on the previous slide and look at the x-coordinates of the vertex of each graph. So we're going to look at the x-coordinates of the vertex of both our red and our green graphs. So if I look at just my red graph, I see that my vertex is 2, -6. And for my blue graph, I see that my vertex is 2, -2. So if I'm focusing on just the x value for both of these graphs, that x value is 2. So x equals 2 at the vertex of both graphs. So our equations were very, very similar. They were a little bit different, but the equations, even though they were a little bit different, still gave us the same x value for our vertex. So we're going to explore about why that is. So we're going to use the graph of y equals 2x squared minus 8x to find its x-intercepts, or that would be the first graph in our system. So let me go back and erase again. Okay, so looking at the first graph, or the red graph in our system, I want to identify the x-intercepts. So here I see it crosses my x-axis, so this has an x value of 0. And it crosses my x-axis again here, where x is equal to 4. So what I have decided is that my y value is 0 when x is 0, and my y value is 0 when x is 4. So these are my two x-intercepts. So I use the graph to find my x-intercepts. I've got 0, 0, and 4, 0. And they ask us to verify our answer by solving this quadratic. So in order to solve, I factor. Factoring here, the only thing I can do is take out the GCF, which is 2x, leaving me with x minus 4. And then each piece of my factored form I let equal 0. So my first equation leads me to x equals 0. My second equation leads me to x equals 4. So I have my two x-intercepts, and I found them by letting y equal 0. So when y is equal to 0, my first answer tells me that x is 0. And when y is equal to 0, my second answer tells me that x could be 4. So there are two different x values that give me a y value of 0, which is exactly what we had found just by looking at our graph. So we can find those x-intercepts two different ways, by looking at the graph, or by solving by inputting 0 for y. Now I'd like to go back and look at our graphs one more time and compare our X-intercepts to our vertex. Now keep in mind that parabolas are symmetric. So if I fold my graph down that green line, the left-hand side is exactly the same as the right, which means that the distance from the line to my x-intercept has to be the same going to the left and going to the right. So to get from my line to that first x-intercept, I go to the left 2. To get from my line going to the right intercept, I go to the right 2. So sure enough, that line of my axis of symmetry, or my vertex, this point here, is exactly in the middle of both of my x-intercepts. And the reason that is because parabolas are symmetric. The left and the right must be identical, which means our vertex must be in the middle of our two x-intercepts. So compare the value of the x-coordinate of the vertex with the values of the x-intercept. So vertex is in the middle of x-intercepts. Okay, we're going to move on and solve by factoring. So in order to solve, I need to factor. The GCF here is x, leaving me with ax plus b. I then solve by letting x equal 0 and by letting ax plus b equal 0. Now I'm trying to solve for x, so that means I need to get rid of my b, which leaves me with ax is equal to negative b. And then I divide by a, leaving me with x is equal to negative b over a. So I have two answers. My first is that x is 0, and my second is that x is negative b over a. So when my y value is 0 in our equation, then my x values are 0 and negative b over a. So if I'm looking for the x-intercepts of this graph, whatever a and b might be, I would put in a 0 for y and then solve the equation, which I already did above. So that means that my first x-intercept, I have a y value of 0, and then I saw by solving before that my x value will be 0. Option 2, I have a y value of 0, and I also got a solution of negative b over a. So I have two x-intercepts on my graph of y equals ax squared plus bx. We can verify that by completing my table. If I put in a 0, if I plug in a 0 to this equation, my y value is going to equal 0. If I put in a negative b over a, I'll actually multiply that out. I start by doing exponents first. So negative b over a all squared. Negative b times negative b is positive b squared. A times a is a squared. And then I have b times negative b, so negative b squared over a. When I reduce my fractions, one of my a's reduces on the bottom, leaving me with just a in the denominator. So my y is equal to b squared over a minus b squared over a, which is in fact 0. So we have shown that if I plug in a negative b over a, I will also get 0. So we started by solving by factoring. We then found the x-intercepts, and we verified that answer by plugging these x-intercepts back into our equation to make sure that we do get a y value of 0. I'm going to go ahead and end this video here, and I will complete the rest of this lesson in a second video. Thanks so much for watching.